Okay, so let's talk about multiplying polynomials now. Now, multiplication doesn't care if things are the same. You with me? I can multiply anything I want together. It's like making a fruit salad. We put this, we put that, we just keep putting things in there, and it doesn't matter that they're not the same. We just keep putting stuff together to make a fruit salad. Well, that's multiplication for you. Are you with me? So take a look at this first problem. Again, notice it says simplify, which means do the operation they ask you to do. So, in this parenthesis, what operation is between the 6 and the a? Yeah, it's multiplication. And in this parenthesis, yeah, that's multiplication too. 6 times a, 4 times a. We're just used to saying 6a and 4a, right? 6a, 4a, but it's actually 6 times a, 4 times a. And in between these parentheses is also multiplication. So technically, I could write this problem as 6 times a times 4 times a. We don't write it that way, but we could. So you get where I'm going, right? Which means if I'm going to multiply these, I'm going to multiply what I can multiply, right? I can only really multiply things that are somewhat similar. Like the 6 and 4 can be multiplied. What do you get? Sure, we get 24. And then you're left multiplying a times a. Well, a to the first times a to the first is a to the second. Because you add those exponents, don't you? Cool? Good. And I know this might be review for some of you, and that's great. So just bear with me. I need to make sure everybody's on the same page. Cool? All right. Number 2. There's a lot of multiplication going on, right? This is technically a -1 in front, isn't it? Even though we don't see the 1, it's technically a -1. Times a squared times b squared, right? And then you've got 4 times a times b to the 4th, don't you? So again, technically, if I really wanted to, I could write it out this way, even though we don't, because when we write it out this way, that just looks sometimes a little more involved than we want it to be. But you get the drift. Okay, so what are you multiplying? Good, the -1 and the 4. Multiplying gives you -4. What else are you multiplying? Sure, a squared and a to the first. They're not exactly the same, but they both have a's. So I can multiply them together. So what do you get? Good, a to the power of 3, because there's a 2 and there's a 1, that's 3, right? And then the b's, b squared times b to the 4th. b to the power of, good, 6. Because you add the exponents together, don't you? Cool? Okay, let's look at number 3 here. Now, number 3 is our distribution problem, isn't it? Because this -4ab on the outside has to get multiplied, because technically there's multiplication between it and the parenthesis, right? It has to get multiplied to all 3 of these terms, doesn't it? Okay, so for some of us who are visual, we may literally want to write down the multiplication problems we have to do. So I have to take the -4ab and multiply it by what first? Good, the a squared b. And then I still have to take the -4ab and multiply it by what? Good, the positive 3ab, right? And then I still have to take the -4ab and multiply it by the -4b squared. Cool? Here are the 3 separate problems that I have to work on. And by the way, don't they look like problems 1 and 2? Yeah, that's why we need to make certain we know how to do problems 1 and 2 very well, because problem 3 and subsequently the rest of the problems we're going to work on really do break down to us knowing how to do problems 1 and 2. Cool? All right, so here, when you multiply these two, what do we get? Good, you get a -4, a to the 3rd, good, b to the 2nd. Good job, excellent. How about multiplying these two parentheses, the second set? Good, we get a -12, a squared, b squared. Good. And multiplying these last two. Yeah, that's a positive 16, isn't it? just a, because there's no b in that one, right? And good, b to the third. Okay, so we're ready to write this down, aren't we? Let's get descending order going. Which one's first in the alphabet, the A's or the B's? The A's. So, yep, that one's got the highest A power on it, so 4a cubed b to the second. Good. Minus 12a to the second, b to the second. So a to the third, a to the second, and that's right, 16a to the power of 1 and b cubed. Good? Y'all with me? Stay tuned. Got some more distribution problems for us. Okay, so let's look at this next problem. Now, this one is like problem 3 that we just did, except instead of one distribution, we're going to have two distributions. So watch and see how I approach this. And yes, there is another way to approach it that some of you may actually already know. And if you like the other way, then by all means, please use it, okay? But I like to use the distribution method because it'll work if any of these parentheses are trinomials. Anyway, I'll leave it there. So, on problem 3, we had one term in front of the parentheses, so that one term got distributed to everything inside the parenthesis. In this particular case, problem 4, I actually have two terms in front of this parenthesis. One of the terms I have is an x, right? Another term I have in front of that parenthesis is a -3. So here's the deal. I like to call this a double distribution. I am going to take that x and I'm going to have to distribute it to the 2x plus 4. But I'm also going to have to take this -3 and distribute it to the 2x plus 4. So instead of one problem to work on, I actually have two problems to work on. No big deal. We know how to do these distributions. We know how to multiply this. Are you with me? Okay, so let's go to this first distribution. I'm going to do the x times the 2x plus 4, the 2x, right? And then I'm going to do the x times the positive 4, aren't I? And when I do this distribution, I'm going to get, good, 2x squared, and then a positive 4x. Agreed? Okay, this second distribution, I'm going to take that -3 and distribute to the 2x. But I'm also going to take that -3 and distribute it to that positive 4, aren't I? This will give me a -6x, and this will give me, right, a -12. Does that make sense? So I'm left with 4 terms. I'm left with 2x squared and a positive 4x. But the other distribution left me with a -6x and a -12. And when I write those 4 terms down, I notice that 2 of them can be combined, can't they? Yeah, the middle 2. Do you see it? All right, which gives me 2x squared minus 2x minus 12. Anything else I can combine? No. Is it in descending order? Yes. So am I done? I am. I did what they asked me to do. I multiplied. So again, problem number 4 was like problem number 3, except instead of one distribution, I had 2 distributions to do. And this is one way to look at the 2 distributions. Again, if you like the other method, that means you know how to do this very well, and so by all means use it. But some of you who still need a little brushing up on multiplying polynomials, or, you know, maybe you don't know how to do them at all, this is one method that I like to show. Cool? By the way, the more you do these, the quicker they become. So FYI. Okay, so let's look at problem number 5. Notice in front of this second parenthesis, I have 2 terms again. I have 3x and I have a -2, don't I? So I'm going to have to take this 3x and distribute it to the 5x plus 1. Agreed? But I'm also going to have to take that -2 and distribute it to the 5x plus 1. Both of those are in front of that 5x plus 1 parenthesis, right? Okay, and now I notice this 3x, I'm going to have to multiply to the 5x, but I'm also going to have to take that 3x and multiply to that positive 1, aren't I? So what do we get when we multiply? Good, we got a 15x squared, and we have a positive 3x, don't we? All right, this second distribution, I'm going to have to take this minus 2 and distribute to the 5x, and this minus 2 to the positive 1, right? So I'm running a little bit out of board space, but hopefully you can see this is a negative 10x, and this is a minus 2. Yes? Good. Again, 4 terms. We have the 15x squared, we have the positive 3x, we have the minus 10x, and then the minus 2. Can I combine anything? Yes, I can. I can combine those middle two, which will give me a minus 7x, and I have this trinomial that's left over in descending order. Good? Does this make sense? Cool. Hang in there. Got another one for us. Okay, so let's look at problem 6. Now, do you notice in problem 6, the second parenthesis has 3 terms in it, doesn't it? Okay, that doesn't change our process any. I'm still going to take the number of terms in the first parenthesis, and each one is going to have to distribute to the second parenthesis. Are you with me? So I'm still going to have to take this a, and I'm still going to have to take this plus 2, and I'm still going to have to distribute both of those to the second parenthesis. So let's write that down. Now, some of you, I know, are asking, do I have to write all these steps? You know, the more familiar you become with distributing these polynomials, the fewer steps you actually need to write. But in the beginning, when you're first learning how to do them, yes, I recommend writing it. Cool? All right. So let's look at this first distribution. I'm going to have to take this a, and I'm going to have to multiply it to the 3a squared, correct? But this a also has to get multiplied to the negative a, and that a also has to get multiplied to that positive 5, doesn't it? So let's see what this gives me. 3a to the third, a negative a squared, and a positive 5a, right? Okay, and then I am going to have to take this positive 2 and multiply it to the 3a squared, and also to the negative a, and also to that positive 5, right? By the way, that's a positive 2 if you want to put the plus sign in front. Doesn't need to be there, but some of you may want it. So what does this give me? Looks like 6a squared, looks like a negative 2a, and looks like a positive 10. So far, so good? Okay, so now in this case I have 6 terms. So let's start over here on our first distribution. We have 3a to the third minus a squared plus 5a. Agreed? On this other distribution, I had a positive 6a squared. Well, I'm going to line that up under the other a squared, because eventually I'm going to have to combine like terms. Agreed? Okay, and then I have a minus 2a, which I'm going to put under that 5a, and then I just have this plus 10 over here that doesn't belong to anything. It's not like anything else. Good? Okay, so combine your like terms. So you have 3a to the third, and what do you get here? That's right, plus 5a squared, plus 3a, and then plus 10. Is there anything else I can add together? Nope. Is it in descending order? Yep. Now that's a 4-term polynomial, right? Then it's just known as a polynomial. It's not a trinomial, it's not a binomial, it's not a monomial. Since it's 4 terms, we just simply call it a polynomial. What degree is it? Yeah, that's a 3rd degree polynomial, isn't it? Good? Okay, now let's look at this one. Sometimes they may actually give you problems that look like this and ask you to multiply. You're like, what do I do? You do with this the same thing you do when you first learned how to multiply numbers together, way back in grammar school somewhere. With me? I am going to take this plus 2 and I am going to multiply it by all three terms, just like I learned way back when in grammar school. All right? So this plus 2 is going to get multiplied to that negative 1. That'll give you a negative 2, won't it? And this plus 2 gets multiplied to the positive 2m. What does that give you? Good, a positive 4m. And this plus 2 gets multiplied to the 3m squared. Good, that gives me a 6m squared, doesn't it? Okay, but I still have to take this 5m and distribute it to all three of these. So the 5m to the negative 1, what do you get? Good, negative 5m. So I put it under the like term of the 4m. And this 5m to the positive 2m, good, a positive 10m squared. So I'm putting it under the m squared term. And lastly, 5m times 3m squared, good, that'll be a 15m to the third. And then I get to add them. And as I'm adding my like terms, I'm grateful that it is in descending order, so I don't have to worry about it. Cool? Okay, now some of you are like, I don't like the way they set that up. Well, then here you go. Let me ask you a question before I write down, here you go. Does it matter the order in which you multiply things? No. If I do 5 times 7, it's the same as 7 times 5, don't I? Isn't it? Okay, so when I multiply polynomials, it doesn't matter the order in which I multiply them. This first polynomial is 3 terms. The second one is 2 terms. Here's what I like to do if I don't like this setup. I like to take the polynomial with the smallest number of terms, which in this case is 5m plus 2, and I'm going to write that first, and then I'll distribute it to the trinomial. So if I don't like the way they gave it to me, I'm just going to rewrite it and do my normal distribution. So this is an alternate way of setting up the original problem. And by the way, this problem looks like number 6, doesn't it? And we know how to tackle number 6, don't we? Make sense? Cool. Hang in there. I'll be right back with one more. Okay, so let's look at this last problem. Now, this one's kind of interesting because you have a parenthesis within a parenthesis, don't you? Well, first questions first. According to the order of operations, we tackle parentheses first, and inside this bigger parenthesis is an x plus these 2 terms. Now, is anything alike in here that I could add them together? No, you're right. There's nothing alike, so I cannot add them together. So after parentheses comes exponents, right? So I see this exponent, and it's sitting on this parenthesis. It's the outer parenthesis, isn't it? Which means I've got 2 of those parentheses. So me being a visual person, I'm going to write this out twice. I have got this parenthesis, and I've got it written a second time. You with me? Okay. Now, I want to be honest with you. From here, there's like 2 or 3 different ways you could actually go to take care of this distribution. One way I'm going to approach is I'm going to approach it the way that we were approaching the last few problems. Okay? Here is my second parenthesis, and I technically have 2 terms in front of it. I have an x, and I have this smaller parenthesis. So I'm going to have to take this x and this smaller parenthesis, by the way, there's a plus sign in front of it, and I'm going to have to distribute it to each one of these to that second parenthesis, the x plus, and then the smaller one inside. Same thing with this 4b plus 1. I'm going to have to multiply it to that larger parenthesis, because that's the second parenthesis. With me? Okay. Now, you kind of have to take this slow. You can do this. You just have to take it slow and be methodical. So I'm going to take this x and multiply it by this x, just like I did before. But I have to take this x on the outside and also multiply it by that smaller parenthesis that's on the inside. With me? Okay, so let's see what that looks like. This will be an x squared. And what's going to happen here? What do you get? Good, you get 4bx, right, plus x. Agree on that distribution? Excellent. And now, I have got this 4b plus 1 on the outside, and I'm going to have to multiply to the first term, which is x, but I'm going to have to also take that 4b plus 1 on the outside and multiply it by the smaller parenthesis on the inside. Agreed? You with me on this second setup? Okay, so let's look. So you're going to have to take 4b and multiply by x. What do you get? Good, 4bx. But you also have to take this this positive 1 and multiply by the x, which gives you, good, a positive x. With me? Awesome. Now this one. Some of you on this one may need to write this out twice, like do that double distribution like I showed you on problems 4 and 5. And some of you may be able to handle it as it is. What I'm going to show you is handling it as it is. This 4b has to get multiplied by that parenthesis. So it's 4b times 4b. Good, 16b to the power of 2. And this 4b also has to get multiplied by 1, which gives you a positive 4b. Excellent. So I'm done distributing that guy. Now I have to take this positive 1 and multiply by both of them. So a positive 1 times 4b is a positive 4b. And then a positive 1 times a positive 1 is a positive 1. Cool? Yeah, and some of you are noticing you can add things together here, right? Okay, so hold on to that thought for just a second. All right, so my first distribution gave me x squared and a positive 4bx and then a positive x, right? This distribution, I have a positive 4bx, which I'm going to write under the like term, and a positive x under the like term. Got it? Okay, over here, a 16b squared. Well, that's not like anything, so I'm just going to tack it on at the end. And then a positive 4b. Yeah, that's not like these guys. These guys have an x. This one doesn't. So I'm just going to tack it on at the end. And another positive 4b. And then a positive 1. None of these guys look like any of these here. So let's add our like terms. We've got an x squared. Oh my gosh, I'm so sorry. Yeah, some of you are like, wait. You know, you're right. That second 4b looks like this 4b, so let's write it under it. Good catch, you guys. Nicely done. Good job. Okay, now let's add like terms. Plus 8bx plus x plus 16b squared plus 8b and plus 1. Well, this was an interesting distribution problem, wasn't it? Like I said, there's like 2 or 3 different ways you could have gone from here. My recommendation is you take this problem slowly. Just understand that that square is going to make you write the big parenthesis out twice. And after you write it out twice, it's your choice which direction to go from there. Cool? Okay, and some of you are going, is that in descending order? Well, because this is an interesting problem, I personally would leave it in this order. I know B comes before X in the alphabet, but you know what? Some authors of the book are actually just going to leave it this way. Some will move it around, but I would just leave it this way because there's just a lot going on with it. Cool? Okay, you have fun with multiplying polynomials together, and I'll catch you on the flip side.